Hello, everyone. Thank you so much for joining us. Welcome to our beginner-friendly system design series. Before we get started, I just want to give you a brief overview of the event series itself. So the goal of these talks is to help you get started with the system design on real-life app examples. And during each event, we are going to talk about how to build a certain app from scratch, from the system architecture perspective. And we will focus on 3 to 5 core app features that make that system unique. So no coding, just conceptual overview. And today's session is called How to Build Google Photos from Scratch. And we are going to focus on its 4 core features. So photo storage and management, search and organization, sharing and collaboration, and then backup and sync. And we try to host as many of those events as possible. And our next event is going to be next week. So please follow our LinkedIn and YouTube channel and our community platform to be notified once we post a new event. I'll share a link to our community page in the chat soon. But to, yeah, we want today's session to be as interactive as possible. So feel free to drop any questions you have in the chat and we'll answer them live. And now I want to introduce you to our speaker, Alan, who is a Google developer expert, I guess, in everything.
Not quite everything, but
yeah. And so thank you so much for joining us. And yeah, take it away.
okay, thank you. So we're going to be talking about how to build Google Photos from scratch today, and this is actually a topic that I've thought a lot about over the past 10 years. So let's start with who am I? I'm a software developer and I'm a consultant located in New York. As mentioned, I'm a Google developer expert in a wide range of stuff, including Google Cloud, Google Workspace, and Google AI. I'm also a LangChain.js champion, which means that I've worked closely with the LangChain team to help integrate Gemini into the LangChain product. As a Google developer expert, I don't work for Google, but I work closely with them. And I talk to their engineers a lot. I talk to their DevRel people a lot. And I kind of have a sense of a lot of what Google is going, kind of have this fairly big picture, which I think helps for this kind of a request. I'm also the co-host of a podcast called Two Voice Devs. I encourage you to tune in where we talk about how to look at things from a design and developing point of view. How do we develop this new generation of technology? So I kind of want to take this as kind of a narrative story. Let's say I got an email from my boss this morning saying he just saw that Google Photos just turned 10, and it did. It just turned 10 years old a couple of days ago. What if we added it to our product suite? He's attached some design thoughts, but he wants a Miro design by Monday morning. And as kind of outlined, those thoughts were, how do we address the photo storage and management, including a storage engine, deduplication, scalable metadata storage? What about search and organization? Do we have a tagging engine, index and service albums? What does sharing and collaboration look like? And that includes access control, link sharing, shared albums, real-time sync. And how do we do this backup and sync? And looking at this set of ideas, and in fact, this whole email from him, a bunch of things jumped out at me as very odd. And I had the distinct feeling that he actually kind of just fed this into ChatGPT and cut and pasted the answer. So I look at this and I'm like, so why is he asking for a Miro design? I don't know Miro. I've never used Miro. My boss has never used Miro, so I don't know where that came from. This whole thing, and nowhere in there did he say what the UI should be like or that there should be a UI at all. Maybe that was just an assumption. And oh goodness, this does not describe Google Photos at all. There are so many things about it that are not part of Google Photos. So part of me is saying, well, okay, this was a nice inspiration, but what I think we really need to design is we need to go in and let's take an actual look at some of the features and some of the components that we're going to be needing step by step. So let's go open up Miro. which, as I said, I have not used before, but that's what my boss wants, so that's what my boss is going to get. And the first question, I actually have my first set of questions before we do this is even three things. Why are we doing this at all? My boss said they want this as part of their product suite. Well, I'm not so sure it fits well into our product suite. Maybe I'll mention this in the email that I send my boss later. But why not? This is a fun exercise regardless. And then thinking about it, we've got some interesting ideas here, but what's the easiest way to get there from here? What are some of the simplest things that I could be doing just to get this working? So part of me says, well, Google has a Google Photos API. So what if we just stick this API here?
I don't know, but I found these.
Ooh, okay. So what if we just stick this API here and we connect the two? How does that work out? Yeah. Well, the problem with this, and this is not necessarily a terrible idea, but the Google Photos API doesn't do everything that I think we really want it to do. And quite honestly, I think my boss might catch on to that fact pretty quickly. So let's not go with that. What instead if we just, use Google Drive? And we're just going to, again, just kind of stick Google Drive here. And, just connect these up. And again, that's probably not a terrible idea. Because Google Drive has some of the stuff that we need. It's got the storage, it's got, some indexing, it does have searches, so it does some things. But again, I have a feeling my boss would catch on pretty quickly. So we're not going to do that. Instead, let's kind of look at this whole thing and exactly what it is that it needs to do. So let's take a quick look at this app, which I've already courteously provided the icon for. So I don't do apps. This is one of the things that my boss knows about me. I don't do apps. So I'm going to leave him a sticky note that just kind of identifies a couple of things that I think might help out here. So I'm going to suggest that and this is a good place where Flutter might be something that is useful for my boss to work on here. Flutter is nice and cross-platform, so we can develop a mobile app for both Android and iOS, and something for the web. And that means that when we're hosting it, we're going to need Firebase hosting and Firebase app hosting as well. So I think this is a pretty good set of tools for my boss to use. So good. We've got something that my boss can start out with right away. Fantastic. And I'm already having trouble figuring out how to move around this screen here. So we're doing well so far. So good. We've got one thing already done. The app. We've delegated that. So that's great. So what's next on our list of things to look at? Well, so we want to now look at maybe storage and metadata. Got a lot of approaches here. But basically, we're going to need two sets of information. One is we need to actually store the photo itself. So we're going to need a way that we can just, someplace to put these photos. And kind of the obvious one here is, and let me see if I can, that's not what I want. I'm also trying to use a set of remote icons so that we can play nicely here. So what I want is cloud storage. Here we go, cloud storage. And with this cloud, so this is going to be what we'll use to store just the files themselves. Cloud storage is a nice place that we can basically just dump objects to. And we can assign them a content type, and we can give them some metadata. But really, this isn't a great place for us to store the metadata. And when I say metadata, we've got like a bunch of things that we're going to be storing, that are associated with the file. So we'll want to know the original file name. In some cases, for example, when we put it in our cloud storage bucket, we're going to give it our own internal identifier. So we don't necessarily want to, keep using that. We don't want to expose that to the public as well. But we want to make sure we keep the original file name. We want to keep original things like when it was taken. And we want to keep things like location data. And the photo itself contains a lot of information in some cases. So it may contain, the camera that it was taken on. If it was taken from a mobile device, it'll have location. If it wasn't, it might contain things like shutter speed or aperture or a ton of other information that's available. And then, as we're getting towards search, there are other attributes that we may want to search on. Or when we start talking about what albums it's going to be in, that's other information that gets attached to a file. So there's lots of information that we associate with a file, but isn't really the file itself. And that's what metadata is. And here we've got a number of fairly good choices. So we've got AlloyDB, which is a traditional PostgreSQL-like database. We have something like Vertex AI Vector Search, which stores it in a particular vector format. That's not going to be as good. It's mostly focused on the vector storage element of it. So AlloyDB seems like a fairly good choice there. It's certainly a fairly standard choice. But we also have, and this is one that I particularly like, is something called Firestore. And if you've heard of the Firebase real-time database, Firestore is kind of the next generation of that. And it does a lot of things. So it has these broad collections of broad idea of what it calls a collection. And a collection is a collection of documents. And these documents can essentially be our metadata. So that seems really, really appealing to me for a number of things. Firestore also has some fairly robust indexing. It's got fairly robust searching, and it has really, really, really good security all built in. So I feel like we're going to go with Firestore. And so let me find the Firestore icon here. Here we go. And
so again, just to clarify, essentially cloud storage would be used for actually storing the actual pictures with metadata, right? And for Firestore, it would be, so we would use it for.
So cloud storage, and I'll let me annotate these. You can't see that text at all. Wow, can you? I certainly can't anyway. So cloud storage would contain the image files, and cloud storage uses the term objects for that. And then we're also going to have, you're not going to just automatically do that for me, are you? Oop, that's not where I wanted to put it, though. And there's got to be a way to move this around. Oh, I'll figure it out. And Firestore is going to store the metadata. And, you know what? We're probably going to have other tables here in the future, so we're just going to leave a metadata, a general metadata, but we'll note that it includes that metadata includes the owner of each file, and of course, there's going to be a reference from Firestore itself to the cloud storage, and so that talks about our storage. That's pretty good. We've got some other things in here that are going to be useful to us. So, for example, it's going to contain the image file stored as an object, and it also is going to be containing versioning information. So if, for example, the person uploads a new version of a file, or if they've edited a file, it will contain multiple versions of that file. And that's a native feature for cloud storage. If I resize it, look at that.
Yeah.
That might actually be more legible to everyone now.
Yep, perfect.
See, why my boss told me to do this in Miro, I have no idea. Okay, so we now have where we're storing it, but we don't actually, I can't actually draw a line yet between our app and our storage system, because we don't really, have that. But let's see. What if we now set up this API front end for it? And we'll just mark this as we'll mark this using a much larger font size. There we go. Okay. An API that's on Google Cloud Run. And we will treat this all as one unit. No, we won't. I don't like that idea the more I think about it. And we'll see why I don't like that idea in a little bit. So now it'll the app will send things to our API, and our API, oh, look at that. That automatically just does it. Nifty. Yep. You're not going to just automatically connect things nicely the way I want to, are you? Okay, maybe not. And it connects it to Firestore. Okay. Much neater. So, okay, so we've kind of tackled our first problem. We're going to have our app. We'll save stuff to Cloud Run. When it saves it to Cloud Run will both save it to cloud storage and index it in Firestore. Sounds good so far, right? Excellent. So the next big feature is search. And when Google Photos launched 10 years ago, that was one of its biggest features at that point, was being able not just to add photos and to tag them, but to be able to search for them, to do topical keyword searching. So you weren't just, you didn't just have to say, oh, I tagged this vacation 2015, or I'm searching for it on a particular date. I could look for pictures of my cat, and not just any cat. I could, make it my cat. And it was doing, I look for pictures of this person, or I could look for places where I had a picture of a brick wall. Why was I looking for a brick wall? Never mind that. We'll talk about that at another time. But, so we have two different kinds of searches that are going on here. One of which is this metadata search, search by date, search by location. And we also have this broader topical keyword search. Search for sunsets, search for sunrises. So how do we do this? And that's actually kind of an interesting split. we're going to need two different methods to tackle these two kinds of things. So let's kind of look at those two elements. So we're going to have another API, and again, it'll be by Cloud Run. So this is now the storage API that we have in Cloud Run. We're going to need another one.
And just to clarify, basically, the reason why we don't have just one API that does everything, so we don't combine storage and search, just because we want to have those services split, right? So in case we need to scale them up, they're more isolated, right? And we can, like, for example...
Well, again, I'm looking at just a broad system design here.
Yeah.
So when we actually go to implement it, we may say this is part of a monolithic server,
Okay.
or we may say that these are individual cloud functions that are part of Cloud Run,
Mhm.
or we have a bunch of other different possible approaches. But this is a logical system design right now.
Makes sense. Makes sense.
So I'm not trying to address what's the right breakdown for where these API lives. I'm identifying the need for different kinds of APIs, because the requirements for storing something
Mhm.
are very, very different than the requirements for searching for something. Or
Okay.
even, the requirement for just getting a listing of all of my photos. That's simple and straightforward and quick. Whereas searching for specific ones it requires a different approach.
Mhm. Yeah, makes sense.
So
Just one side note, after we cover like the basic features, also can we talk about like how it would scale, like for example, once we get more users, and also like for example serving different parts of the world and stuff
sure.
like this?
So well, we could try. We've got a lot of basic features coming here, but
Yeah.
and I'll try to address some of that as we go along. One of the nice advantages of using something like Cloud Run, however, is that a lot of that scaling is already part of it.
Mhm.
And one of the things that we'll see is that as we go along, kind of certainly as we're doing our initial design, we can just assume that Google is going to be taking care of a lot of the scaling for us. All of the design we're going to be looking at here is pretty much a serverless design.
Mhm.
So Google will handle a lot of that scaling. And I'll
Mhm.
discuss as we go along where, or flag me if I don't mention it, where some of those things aren't being addressed.
Mhm. Sounds good.
As for regional storage, that's a great question, and a much trickier one that you could probably spend an entire session going through. We'll try to touch on that as well, though.
Sounds good. Sounds good.
So the search API, as we mentioned, kind of has two different sets of requirements here, kind of two different kinds of things that we need. So let's add a post-it note. Where'd my post-it notes go? I know they were here a minute ago. Stickers, wasn't here. Nope, that wasn't it. Oh, come on, where'd the post? There we go, sticky notes. So let's add another sticky note here, just to remind myself. So we need to address two different types of searches. We need to do topical, well, let's do metadata first. And topical or keyword searches. So this is just to remind us we do have these two different types of things. And let's kind of look at, well, and then, now that I think about it, there is actually a third type. And that's combined searches. So I might want to search for brick walls that I took in November of 2025.
Yeah, makes sense.
Okay, so let's tackle these one by one. So for the metadata search, what is that going to look like? Well, metadata involves Firestore. So we already kind of have that built in. We're probably indexing a bunch of our crucial fields. We're indexing the metadata. So that's a pretty straightforward thing that we can include. Fantastic. one thing already done, making it easier. And we don't even need to add any new tables. We don't need to add any new indexes. We don't need to add anything special here. Topical keywords. Well, that gets a little more challenging. And here's where we start to look at something that most of us have only recently learned about, and that's called embeddings. So we're going to need, and I'm just going to put this kind of here right now as a blob. We need an embedding engine. So an embedding, the best way to describe embeddings is that embeddings take something. We don't know what it is. Mostly we talk about embeddings in terms of text, but it could be images, it could be videos, it could be anything. It takes something and turns it into a whole bunch of numbers that represent what that thing is. And we will refer to that sometimes as a semantic embedding, because it doesn't refer to characteristics of it. It doesn't represent specific pixels, for example. It doesn't represent specific colors when we're talking about photos, but it represents concepts, ideas. This is a picture of a book. This is a picture of a sunset. This is a picture of books and knickknacks. It's more complicated than this, but we can sort of think that's kind of how we think of it. And we think of it as how much of a nature of something it has. So if we look at a picture of a bookshelf, like the bookshelf behind me, or if we look at, say, my picture, this picture that you're seeing of me right now, there's a bookshelf there. So there might be some nature of a book. Maybe if we rank it from -1 to 1, where 1 is very much this thing and -1 is very much not this thing, then maybe it's a 0.1, 0.2, because there are some books in this picture. If we rate it on the nature of telephone, well, there's a telephone hanging on the wall if people recognize it, but it's not what we think of as a telephone. So maybe that's a 0.2 or a 0.3. If we are ranking it on the nature of it being red, well, there isn't a lot of red in this photo, so maybe we rank it on as a -0.5 or a -0.7.
Mm-hmm.
So embeddings have many of these kinds of categories.
Yeah.
Sometimes several hundred to several thousand, and it's just a set of numbers. So what do we do with these numbers? Well, the neat thing is that we can use some mathematical properties, dot products, cosine similarities, basically some math that says, if we have 1,000 of these numbers, we can think of this as a 1,000 dimensional space. And if we have multiple points in this 1,000 dimensional space, how close are they to each other? So if I then come in and say, I want to search for a brick wall, okay, that phrase, I want to search for a brick wall, turns into another set of those numbers. And then we look for how close that set of numbers are to all of our photos. And then we find the closest ones in that n-dimensional space. Embeddings are something that I could talk about for half an hour. We could do examples. We can do code samples. We can do interactive examples. We don't have time for that today.
Yeah. We can change it into the black box. Yeah.
So take my word for it, is that we're going to have something that will turn a photo into this set of numbers and turn that phrase into that set of numbers. And then something that will do that matching. So we actually have two, we have an embedding engine and an embedding matching engine that we're going to be working with. So the good news is Google provides this for us as well. So we do have a multimodal embedding engine called and I believe that's even the name of it, is multimodal. It's an API that provides multimodal embeddings, and we can store this in Firestore. So our metadata for a file includes the owner and it also includes the embedding.
Would it be the most effective way of storing this embedding there? Or it's better to store it in a separate like vector database?
So it's a good question. Would it make more sense to store it in a vector database, such as Vertex AI Vector Search? And it's a good question. I'm thinking in this case, it's actually best to include it in Firestore for two reasons. One, Firestore does include this feature. So it's a feature that Firestore supports. And two, we'll get to in a moment.
So is there like a separate, basically, I haven't worked with embedding specifically in Firestore yet, but is that like basically, is it like a toggle where you say store embedding for it?
It's just another data type as part of Firestore.
Oh, okay. Awesome.
So we now have our multimodal embedding engine. Okay, so that takes care of our regular metadata searching, and it takes care of our topical and keyword searching. We're probably also going to need to have some things in here so that when we actually store something, we actually do that indexing as well, but we can handle that. Not sure I like how these lines are being drawn, but that's my boss's problem. So now how do we deal with that combined thing? So in some cases, we're going to need to do, we essentially need to do a partial search over the metadata, and then from the results of that, do an embedding search. And this is why storing it in Firestore makes the most sense, because we'll be able to essentially take the data in Firestore, filter it based on the metadata, and then say, and based on that result set, filter it based on or rank it based on these embeddings. So we have a one-stop shop that does that. We're still going to need a little bit of logic here. How do we, so if I say, I want to search for something from November 2025 or November 2015 that has a brick wall, I still need to split that query into two parts. So here is a place where, and you're going to see us doing this a whole lot. Let's just throw Gemini at that problem. So we're going to have Gemini figure out which part is the metadata in the query and which part is the topical keyword in the query. And we will let it solve that problem for us. Okay. So we now have two things done. We've got our storage figured out. We've got how our search is going to work. We've got some components for both of them. This is working out really well.
Awesome. So just maybe one quick question about this Gemini part. You said that it would split the query.
Yep.
So let's say it's like a simple sentence. So what should be, can you give like a sample input and a sample output that Gemini?
Sure. So what we're going to have, what a user will typically say is something like, photos of brick walls from January 2010. Mm-hmm. Okay. So we will now take that input. We're going to have to design a prompt for it, where it'll say something like, here is the input from a user. Identify which parts of these are associated with metadata that is associated with a photo, and which parts of these are semantic information that they are searching for. We'd probably have to tweak this a lot. That's an off-the-cuff prompt. I think would work well. So hang on a second. Okay. So that kind of defines for us. So basically, we give it that input prompt that says split it up into these two parts, and it will give us, January 2010 for the list of metadata and keyword and the other keywords to search for. So basically, we're going to have it, and we'll have it return that to us as a data structure, perhaps, using structured output.
Yeah.
So I think the big trick there is coming up with exactly what that prompt needs to be. But again, I'm just doing a system design right now. I could toss that for the future developer to figure out exactly what that needs to be.
Yeah, for sure.
But I mean, it's a good question. This is a case where we can use a fairly lightweight model. All it needs to do is split things up. It needs to essentially identify the keywords and identify the other metadata. And we can say, we may even specify things like metadata consists of dates and locations and other characteristics typically associated with a photo, such as f-stop, shutter speed, whatever.
Yeah, there is one quick question from the chat of can we use NLP and where does it stand in system design?
Excellent question. So we can use NLP, and that's kind of what I just delegated to Gemini here.
Yeah,
is to say, you handle this NLP part, turn the natural language query into a structured query. And once we have that as structured data, then we can apply it to the Firestore API to get the data out that we need to. That doesn't answer the question. Feel free to follow up.
Sounds good. Yeah, I'll let you know if there is a follow-up question. Maybe one last question before we move on to the next feature. So this multi-model embedding engine, right? So its job is to create an embedding for the image, right? And then we store it in Firestore.
Well, it's twofold, right? So one is that it.
Well, basically, this is the question.
I'm sorry. Repeat that.
What about retrieval? So, like, how would we retrieve this data? So,
sure.
Would it be the responsibility of Firestore, or still like multimodal?
Both. And this is the beautiful part. So what happens is let's say we're just searching for a brick wall. So we're not going to deal with the Gemini part right now.
Yeah.
We're going to take that phrase, brick wall,
yeah,
and turn it into an embedding again, turn it into that same set of numbers. And then we take that set of numbers and we go to Firestore and say, locate the 10 or 20 or 30 matches that are nearest to this embedding.
Yeah.
So it's up to, we'll be using the same embedding engine to embed either to create the embeddings in the first place for each picture and to create the embeddings for our search. And that's one of the beauties of embedding engines, is that it's the same thing. You're not doing anything special when you are searching versus when you are inserting.
Okay, makes sense. Awesome.
Okay. So that's good. So we've got our storage, we've got our search. Those were the two big things that it launched with. But it launched with another feature as well that was actually kind of powerful, and that was photo editing and photo generation. And one of the neat things about Google Photos when it launched was that they said it was going to, create these photos for you from your original photos. It would take your photos and it would automatically enhance them. Or it would take your photos and let you enhance them manually. So, okay. I don't know what that component, that's now a little bit different. It's two kind of different things, but in many ways they're the same. Part of me kind of says, you know what? That's a client problem. That's my boss's problem here. But that whole notion of and I think largely we're going to leave it there. So you know what? Let's we'll put that there again, so my boss knows what they need to do. But there is this notion of generating new photos and having Google Photo and having our photo system automatically identify what are good things to enhance. But what is that enhancement going to look like? Well, again, part of me is saying, okay, let's toss Gemini at that problem again. So we have. So when something gets saved via the storage API, when they save a photo, maybe that will also trigger a cloud function. And let me see if I've got an icon for cloud functions here. And what a cloud function, one of the great things about cloud functions and the way they work is that they can monitor a wide variety of activities. So for example, where are we? There we go. So for example, we can tell it to watch cloud storage. And when a new file is added to cloud storage, this cloud function can get triggered. So here's a case where, it would be nice if that was straight. There we go. So when cloud storage gets a new file, when an object is added to cloud storage, or maybe when an object is added to Firestore, the cloud function will get notified of that, and it can take action. And one of the actions that it can take is, for example, to send this image to Gemini and say, how would you enhance this photo? Is there anything that we can do with it? And Gemini might, and maybe we'll have some other prompts to that say, we can brighten it, we can, maybe give it the list of things that are possible. But those changes themselves, they're algorithmic. We don't need to have Gemini make the changes itself. We can just have Gemini suggest changes and do the actual operations itself. So, let's make a note here. Let's where'd it go? Well, instead of having this, we're going to call this the algorithmic image editor. So based on whatever the function determines and what Gemini determines, we may trigger an algorithmic image editor. And again, it will then do that and save it in cloud storage. And in some way, notify the user back that they've done this. So maybe we're going to need a notification queue in here as well. And from here, we're going to want things like, so it may trigger the notification queue, and the notification queue may send a message back to the client saying that something has happened.
Mm-hmm.
Okay. So we've now handled image editing. But you know what? Recently, in recent years, there's been a new kind of editing that Google has introduced with Google Photos called Magic Eraser. And have you used Magic Eraser? It's really pretty awesome. You basically, you take the picture and you either circle or you kind of mark an area of your photo,
Mm-hmm.
and you say, make it disappear. And it disappears. Or, it may, there's some process that will also look for things to make disappear, like people in the background. And, you go and it will go and identify those people in the background, and they just vanish from your photo.
Mm-hmm.
And that's pretty neat and pretty powerful, isn't it? So what if we could do that? Well, we can. So I really, there's got to be a way to better pan around this than the way I'm doing it.
So essentially, it would be like another like called to Gemini, right? Or like
Nope.
Google. Oh, okay.
So in this case, I'm gonna make a slightly different assumption here. So we're not going to use I'm not going to automatically implement the identify and erase, at least not initially. For the first version of this, we're going to have so let's set up our new API endpoint. And this will be the eraser. Let's call it the manual API in Cloud Run. And I ran out of space there again. Okay, so what this manual eraser is going to do, and we're going to need to get some more space for me to focus on this. Let's add our sticky here for what this is going to look like. So we're going to need to get an image mask of what's going to be deleted from an image. So basically, something will need to say, here are the parts of the image that we want to erase. Mm-hmm. And exactly how it determines that, I'm going to leave that fuzzy for the moment. I guess we'll hook this up right away because I feel like it. So how is that, so I've defined an API, that's wonderful. And it's going to get just a list of what needs to be erased, and it does that. So what tools do we have that can do this? So, we find the... So Google has a service called Vertex AI. And the Vertex AI service is the home for a whole host of different API things. And it includes Gemini, to be sure. But it also includes, and I guess we're using diamonds now for AI models, so we'll keep using that. But it also has the Imagen 3 image model. And what Imagen 3, one of the features that Imagen 3 has, it's what's called in-painting. And in-painting is literally a fancy word for magic eraser. That's exactly what the feature is. You give it the mask, you say, make this vanish, and it makes it vanish. It is a fantastic feature that's available with Imagen 3. It's not yet available in Imagen 4, but I'm sure it is coming relatively soon. So we'll take advantage of that Vertex AI API with Imagen 3 to do the in-painting, and of course, we'll save it to cloud storage. We edit the metadata, et cetera, et cetera, et cetera.
Yeah.
So, but that's it. That so we have this feature that is probably one of Google's Photos' most important features, one of its biggest features, and we just turned it into an API call, 2 API calls.
Yeah, wonderful. Yeah, that's I think it's very useful in here as well. Can we also talk about another feature, sharing and collaboration, right? So specifically about like access control and like sharing, seeing who has access to what, because currently, right, in this cloud storage, we share a picture.
Yep, next two things on my list.
Okay, awesome, sounds good. We'll dive into that then.
No, but it's great, it's important, but kind of before we get to it, we actually need to ask one other question, and that's saying, so we've done all of this, but we haven't actually, how are we authenticating this user? We haven't looked at that at all, really.
Yeah.
And yet it's a really, really crucial part of the entire set of components that we deal with here. Let me see if I've got, do they have this listed in my icon chart? They do not. Maybe they do. Hang on. So we've got another. Let me try that again. So we have some, as we said, it's an important issue, and I don't want to make it look like it feels kind of bolted on. So let's make sure we put it here clearly on the side as something that's very important here.
The star of the system, yeah.
It's a bit oversized, but
You can just say auth, like Firebase auth.
Firebase auth.
Exactly, it will be a little bit easier. Yeah.
And it's Firebase. Almost an R in there somewhere. Okay. So we're going to need to make sure that this works with Firebase auth. And Firebase auth provides kind of the information for everything else that we're going to be doing. So our Firebase is basically the gateway for all of these Cloud Run functions that we're doing. So rather than draw the line everywhere, it's here. We know that it's here and that it's important. Really wish I could find a better icon for it. Oh well. So once we have a user's identity, we now attach it to a bunch of things. So we include this in the owner. So it gets stored with a metadata. So it becomes as simple as when we're looking for, what images are owned by somebody, that's just a query into Firestore to match their authentication. Makes it a lot simpler and straightforward, it's more straightforward when we're doing these queries. So you asked about sharing. One of the ways that we can now do the sharing is by using shared folders. And this is the primary way that Google Photos tends to share things, is to have shared folders. So let's kind of see. I wonder if I can move these a bit, because these are now in the way.
Yeah, I think it should be fine. I think if you just, yeah, like this.
There we go.
Okay.
I just want to make sure I had the right things here.
Perfect.
Okay. So now that we have a little bit more space to work with, let's talk about how we want to implement shared folders, or shared albums, sorry. So a shared album essentially just becomes an attribute on a file itself. When we put something in an album, we're now just going to be adding an attribute to that file saying what that album is. And we're going to need a list of albums that a user owns. Normally, we kind of split it up this way interestingly, because we're going to have an album, but we're not necessarily going to say what is in that album. Instead, we're going to make that an attribute of the file, the image itself. And we do that to structure things so that it's easier to figure out what we have access to.
So again, you're just saying we would store a pointer to the image, or like?
Well, what we're going to do, we're going to reuse Firebase. We're going to reuse Firestore here.
Mm-hmm.
So we're going to have our metadata. That's the metadata about each owner, but it's also going to, as part of it now, include what album it's part of.
Mm-hmm.
Okay, and we're running a little bit out of space here, but let's move this somewhat to give us more space. We're now also going to include albums, and each album includes the owner, and includes members.
So just to clarify, so basically you're saying that each image will be in some kind of album, even though it's not shared like publicly, right? So even if it's just my image, it still will be a part of some album in our system?
Well, maybe or maybe not. What this is saying is that, so let's make that more clear.
Optional, okay. Cool.
So we're now saying that we're adding an attribute onto each image that is saying what albums, if any, is this photo part of.
Mhm.
And separately, we are saying we have a bunch of albums. Who is permitted to that album? So that when I go in through here, or when I click on the API and say, give me my list of albums, give me a list of albums that I have access to, or give me a list of my albums or whatever, it will show those albums because it has permission access to it. Then when I open that album, it does a query against the metadata for all of the photos to find which photos are in an album.
Mhm.
And because of the permission system, I can say only permit access to a photo if I am the owner of a photo, and that will give me certain permissions, or if I am if the photo is in an album that I am permitted to. And this is all done using Firebase's Firestore and Firebase's permissioning system, which is tied to Firebase Auth. So there's really nothing else, not much that I need to add here, except some table structures.
Yeah.
That's all part of the permissioning that I can set up and configure. So I don't need to add any more boxes to this setup, as it turns out, even though I just gave myself a bunch of space to do so. Let me.
So, and in terms of like, I guess, shared albums specifically, right? So once the user, so let's say one person lives in one end of the country, so like in New York, the other one is in California. They upload 2 pictures, so one will be stored in one bucket, I assume, right? The other one will be stored in another bucket, or like how do we basically structure it in a way that many people can share pictures efficiently?
So the best way to do this will be to use global shared, a global shared bucket. And when we talk about buckets, we're mostly talking about cloud storage.
Mhm.
So we'll probably use something like global shared cloud storage. If we really were concerned about data privacy or other data concerns, we could have isolated regional cloud storage and attach you to a region.
Okay.
But that might mean that when you've permitted someone else to it, if they're in a different region,
Mhm.
that it becomes less efficient for them.
Yeah.
So
Yeah.
having something using global cloud storage lets, again, Google deal with the replication, Google deal with the scaling, Google deal with how this bucket is globally distributed and accessed.
Yeah. Yeah. Makes sense.
So I basically punted that decision again to, a future problem, which I don't think will be a problem.
Yeah. Yeah. Awesome. Cool. I think our last one right on the list is backup and sync.
So it's kind of following up on one final point I had regarding this album. So one of the things, though, that we will need is that when an image gets added to an album, again, it's going to need to trigger the cloud function, which sends something to the notification queue.
Mhm.
So this, so we've got our, and sends me a notification saying that I've been permitted here. So
Okay.
yeah, the final thing was backup and sync. And, trying to figure out exactly what my boss meant by this, I kind of look at it and I say, you know what? That's a client problem. And it is, because it means that the client itself is responsible for monitoring when things get added to it, when files get added, and that makes them sync into the cloud bucket itself. If we're talking about things like, well, okay, how do we back up cloud storage? This is a case where we can either take, we can take advantage of Google itself doing those backups. We could take advantage of the fact that we've got versioning on the file. So if they accidentally delete an image, we have a way to undelete it automatically. There isn't much more that we need to add for this. It's all kind of built into Google's infrastructure already that we'll be able to take advantage of.
Yeah.
So overall, there's got to be a better way to pan it and to pan things around. I just don't know what it is. Oh, that's what it is. Okay. Yeah. So overall, we've got a structure that I think handles most of the major features of what Google Photos actually does and how people actually use Google Photos today. We've got a way that that when they take photos or want to add photos, we've got a way that it can be stored and correctly indexed. It's indexed so that when we do a search, we can easily access that search through a variety of means. We can either access it directly through attributes or access it through semantic searching, which will take advantage of the multimodal embedding. And then we can combine those two. And we're going to take advantage of Gemini to kind of figure out which parts need to be keyword searches and which parts need to be semantic searches. Which parts need to be metadata searches and which parts need to be the keyword or semantic searches. We've got some editing that's going on. So editing is going to be in the client, but there's also going to be some automatic editing that can take place through an algorithmic image editor that Gemini will take part of. We've got, we're going to be using Imagen 3 to do magic eraser type editing, and that's going to be really powerful. And then finally, all of this access control is done through Firebase Auth, and access to albums, access to photos themselves will be controlled through that, and then managed using the Firebase Firestore permissioning system, which is incredibly powerful and incredibly flexible. So that's how I would design photos in a nutshell.
Yeah, that's awesome. Well, now we have all the puzzles, and now it's just the matter of implementing them. But quick question. Apologies if you talked about it, but just I think
Sure.
reiterate on that. So let's say I have my pictures, right? So it gets uploaded to cloud storage, and then it's private, right? I assume, or it would be like accessible to me only.
No. So let's look at how that works in this scheme. So when you do that, it gets uploaded. The image itself is stored in the cloud storage.
Yep.
The metadata is stored as part of Firestore, and it's tagged with the owner identity. So you.
Yep.
So by default, when you are later getting photos out, what happens? It goes through the storage API again to get the photos.
Yep.
It will be requesting photos that are yours. And Firebase and Firestore are enforcing the fact that you can only get a photo. You'll only be able to find photos that either match your owner identity, i.e. that they are absolutely yours, or that they are part of an album that you are a member of. And that's enforced through the Firestore security system and Firestore Auth.
Okay, makes sense. I think the question, they made sense, but the only, I guess, the file itself, right? So it can be private or it can be public. Is there like an intermediate kind of level where we can actually?
Well, there is no public.
Sorry?
There's no public.
There is no public? Okay.
It's a file is private. And so, so two questions there. One is, are you asking if we're accessing it through the API, or are you saying, hey, if we're just dumping everything into the cloud storage, if we're dumping everything into cloud storage, doesn't everyone have access to everything in cloud storage?
Exactly. Yeah, that was my confusion at the moment,
No,
but I
no,
think I know the answer now. Technically, like storage API has access to cloud storage, and it accesses the right files, right? And it just delivers it to the end user. Like
correct.
if the
Well,
term,
so there are a couple of ways that we can do this. One is that every storage request goes through the API itself and it sends the bytes down.
yeah,
The other way that we can do this is that when it determines what files you can access, it
mhm,
creates a it gets a URL
yep,
for that file,
exactly,
sends you that URL, and then the client goes against the cloud storage directly. And it can do that with a signed URL, so you can't just go browsing through here and saying, "Oh, give me this file."
mhm,
Give me the file number 1, give me 2, give me 3. It'll take you a long time to go and hit them, but you could accidentally stumble across someone else's photos that way.
mhm,
If we use the API to enforce signed files only, those signatures have a limited lifespan. So, every time you need to new one, you'll need to go back to the API to get that signed list of photos that's valid for you.
yeah, okay, makes sense.
So those are two different approaches. Usually, the one that is more efficient tends to be the one where we're using signed URLs, because those URLs
Intermediary.
have a lifetime. They don't need to go through the cloud run. They can be a little bit faster. So you know what? But that's an excellent point. Let's put a little sticky note here that says,
So, do you know how you can currently like share a link to the album, for example, right? Or like a link to the picture itself on Google Photos? But now you mentioned that with a signed URL, it would like expire eventually, right? But that link that you usually share on with Google Photos to a specific photo doesn't expire. So, kind
no,
of,
that's a good point. So one of the things that we can do is have a way to create permalinks. So we
mhm,
can ask, for example, our storage API, create a permanent link for an album,
mhm,
which now means that for the albums, we may also want to add an attribute for a permalink.
mhm,
So that now means also that when we are accessing things, if we're accessing it through the permalink, we
mhm,
now need to do some overrides about um, what permissions a person may have.
yeah,
So this needs to tie into the authentication system that says if we have what's known as what we'll sometimes refer to as a magic cookie.
mhm,
Um, so we now need to also say if the user is in this magic cookie group that's identified with this album, give them permission as well.
mhm. Yeah, makes sense, makes sense.
But that's something that needs to be hooked in through the authentication system.
Mhm. Cool. Yeah, I think it makes sense. I just had a few other questions, I guess, that we can cover later, but um, uh, what about like any kind of CDNs that we would need maybe, or like to maybe speed up the delivery of those files or
It's certainly possible that we could say, let's put a CDN in front of the cloud storage. I think some of it's going to depend. I don't want to over-engineer this up front.
okay.
Will be part of the issue. I
Mhm,
think one of the things that we need to see as we progress is how much are people using using images multiple times.
yeah.
One of the things CDNs are great when you have content that needs to be delivered to a wide group.
Mhm,
If we're delivering custom information to one person, it's unlikely that a CDN is going to get you too much. Either you're going to be using the local storage on the phone, kind of as a CDN. I mean, it's going to it can maintain copies of some of those files
mhm,
for a while, or I'm going to be requesting my own files. How often? Once a day? Well, it's not going to be more than once every few minutes.
yeah.
And at that rate, a CDN doesn't really help us all that much.
Okay, okay. So essentially, it's all about frequency then, right? And the amount of people that access certain information.
Exactly. CDNs are great. If if I was if I was YouTube, or if I was something that was releasing, or if I was Netflix, a much better example. Netflix has systems that pre-deliver their most common content as close to the user as possible.
Mm-hmm.
That's where a CDN really shines, is putting it close to where the user is asking for it,
Yeah.
and asking for it a lot.
Yeah.
It doesn't help me a lot if it's a user that's just going to be asking for it once in a while.
Mm-hmm. What if, like, for example, my personal pictures, right? I have them uploaded on like backed up with Google Photos, so I access them quite frequently, like every single day or multiple times a day. So in this case, would it be worth doing that?
Probably not, because probably the photos that you're going to be accessing the most will be the most recent, and they'll be on your phone still. So they'll be cached locally on your phone. Beyond that, how many photos do you have? I have 30, 40,000 photos.
Mm-hmm.
Putting that in a CDN doesn't make any sense. It's not going to make it any faster than accessing those 30 or 40,000 photos directly from cloud storage.
I see. Okay.
And then I will rarely access all 30 or 40,000. What I will do somewhat frequently are search for them.
Mm-hmm.
And searching breaks the cache. CDNs are just caches.
Mm-hmm.
Fundamentally. A search breaks the cache. So, I guess the best way that I would put it is CDNs are an optimization, and we don't want to prematurely optimize for something.
Makes sense.
And I think right now, I don't think I don't think this is going to take off, to be perfectly honest. I think my boss has, delusions of grandeur when it comes to this idea.
Yeah.
So that's certainly something that if we see an excessive amount of hits against Google Cloud Storage, maybe we'll start thinking about a CDN.
Mm-hmm.
And that's actually something that we haven't mentioned here, is we haven't mentioned the logging, the observability, the auditing that we will want to be able to do. So, we don't see that on this diagram, but maybe I should put in, where's cloud logging? Cloud, oh, here we go. So maybe, I do want to insert here that, we do want cloud logging as part of this, just kind of, and I included in this diagram, and we want, what's the other one here? Cloud. I had it a second ago. Oops. Well. So we have cloud logging, cloud monitoring that are kind of going to be supervising, watching over the whole thing. Everyone's going to be funneling into these as well.
Mm-hmm. Cool. I think one piece that we missed for storage API aspect of it, and like generally storing the images, is we would need to create some kind of thumbnails, right? Like once we upload a picture.
Oh, you know what? That's an excellent point.
Yeah.
So let's talk about how we would do that. So remember up here, we said we've got the cloud function that is checking whenever an image is saved into cloud storage. So this would be a great place for us to have another cloud function that again is monitoring when something gets saved into cloud storage, and is responsible for generating the thumbnails. And why didn't it turn that into a bullet point? I have no idea. Okay. Nope, no idea. So that generates the thumbnails, and that gets included as part of the metadata that we store with each file.
Mhm.
An excellent point. Good miss.
Awesome. Cool. I think we have one last feature that we wanted to cover, backup and sync, right? So how do
We covered that.
We did? Okay.
Yeah.
With the so basically it would be
It's just a file API.
Yeah. Okay. For what about I was just like thinking, how does it know how to avoid like uploading duplicate files, right? It's basically like us keeping track of what we've uploaded, right? And just both in the database and maybe logs as well, right?
So there are a couple of ways that we can do this. One is that Photos doesn't always do a great job of this, so we can also safely ignore that question. But basically, when a file is uploaded, that's essentially part of the metadata, is a signature about the file itself.
Okay.
If we get something that's uploaded with the same signature,
I see.
we can choose to ignore it.
Okay, makes sense. That makes it easy then. Awesome. Great. And I think one last question about like offline.
Actually, let me follow up with one of the other things that we can do is that this function, which is responsible for searching for photos that might be fun to combine. One of the things that it can do is, along with using Gemini to identify similar images, and it would identify that using embeddings again. So if the embeddings are really, really close, it might say they're similar but not identical pictures. It could, through the notification queue, either say to us, hey, are these identical? Do you want to delete one of them? Or if they're similar but not too similar, it might say, hey, let's create an automatic photo montage of these.
Yeah.
And create that and put it back into cloud storage.
Awesome. Yeah, that makes sense. For offline support, it's basically like just device having all the pictures locally, right?
Yeah, that's a client problem.
Okay, awesome. And maybe one last just feature that I remembered. Do you know how like Google Photos like summarizes or gives you some like short videos of like memories or whatever? I forgot how they called it.
They call it Memory Maker or something like that.
Yeah.
And again, this is something that we can duplicate again using this same cloud function.
Yep.
That is responsible for a whole bunch of things now at this point.
Yep.
Is it's using the embedding to say here are 5 or 6 photos that have similar embeddings. Let's go put them together in a chain and build a video out of them and put standard background music attached to them. So again, this same function this function is doing a lot. That is doing things like automatically enhancing videos, automatically identifying duplicates, automatically identifying ones that could be paired in a montage, can also be identifying a series of them that will work well in a video. And all of that at this stage, we can think of as just prompts into Gemini. Here are a bunch of photos. Would they work well as a video together? Yes or no? And we'd identify which potential photos we'd included that using the embeddings.
Yeah, makes sense.
Using embeddings or possibly using other metadata that's matching.
Yeah, basically on the user preferences or like history or whatever data we have about the user, we can just like make.
Well, it's not data that we have about the user. It's data that we have about the photos. We don't care about the user. We care about the photos. So this is just other metadata that we may have. We can say, we can periodically issue queries to say,
create a summary of those.
Create a summary or create ones that, identify photos that are taken in the same spot years apart, or identify photos that have similar embeddings that are taken years apart, or that were taken within the same time frame, or, that turns into fairly standard queries that we can run periodically.
Yeah, makes sense. Awesome. I think that's it then, right? We are done with the with all the puzzles. Everything's connected, so that's nice. Great. So thank you so much, Ellen, for the great uh, talk and overview and explaining everything. And thank you so much to all of our attendees. We hope to see you at the future sessions. Again, please subscribe, follow our community pages. We'll post the events there. And have a great weekend, everyone. Bye.
Thanks very much for having me. Take care.
Bye.